All right. While people are trickling in, I'm going to start this seminar. So welcome to the Hague program on international cybersecurity's seminar series, in which we usually have one or sometimes more, if it's an edited volume, authors to come about to talk about a recent book. My name is Dennis Broeders. I'm professor of global security and technology at Leiden University in the Netherlands. And together with my colleague, Monica Kaminska, we organized this seminar series. Today, we have as our guest, Paul Scharre, who is author of this big boy. Here it is. Author of Four Battlegrounds, Power in the Age of Artificial Intelligence. And he's also, as perhaps many of you will know, author of a previous volume called Army of None, which I personally think is one of the best titles in the field. He is Vice President and Director of Studies at the Center for New American Security. And he will be talking about this book, Four Battlegrounds, sort of sketching the outline of what the argument is about, the role of artificial intelligence in international security. After that, there will be ample opportunities to ask questions. If you have questions and you start thinking about them, feel free to drop them in the chat during, then we can have a look at them already and maybe have a little think. Otherwise, at the end, when Paul is done with his speech, then we can pick up the questions from you directly. So I think without further ado, I'm handing it over to Paul. Paul, the floor is yours.
Well, thank you so much, Dennis, for that very kind introduction. And thank you all for joining this conversation. I'm very grateful to be here and for the opportunity to talk with you all. I imagine that many of you, like many of the rest of us, are trying to understand how artificial intelligence is changing our world and changing global power. And so with that in mind, I'm very excited to have a chance to talk with you today about my book, Four Battlegrounds, that recently came out that touches on many of these issues. China's leader, Xi Jinping, has said that science and technology is the main battleground of global power rivalry. And I think one of the central questions that democratic countries face is, are we ready for this challenge? Are we ready for this competition in artificial intelligence? And what does that mean to be competing in AI? We saw during the Industrial Revolution that nations rose and fell on the global stage based on how rapidly they industrialized. Germany and Great Britain industrialized faster than other countries, and they raced ahead of other European nations in economic power. Russia started the 19th century as the largest economic power in Europe just by virtue of its larger size. But because they lagged in industrialization, they fell behind. And by the turn of the century, Great Britain and Germany had eclipsed Russia in economic and therefore military potential power, as we saw in World War I and II. The engines of the industrial age were then turned from economic productivity to military powers. Factories were repurposed to produce tanks and airplanes. And so technology is a key enabler of political, economic, and military power. And when we think about these historical examples, I think we want to envision that we're Great Britain or Germany in this analogy that will be able to move fast with AI and stay ahead. But deep down, at least for many in Washington, the fear is that we might be Russia and be falling behind China as it rapidly develops artificial intelligence. China has said their goal is to be the leader in artificial intelligence by 2030. I take them quite seriously at that goal. And they're investing heavily in AI, including developing the technology and integrating it across their society. I want to start with a story that I think on the surface paints a picture that China is ahead in AI, and it's about facial recognition. China has half of the world's 1 billion surveillance cameras, and the Chinese Communist Party is building a very developed and very dystopian surveillance apparatus across the country to track and monitor its citizens that is increasingly empowered by artificial intelligence, using facial recognition, gait recognition, voice recognition, using algorithms to monitor people's movements and draw connections between different data points And just as over the last 20 years, we've seen the Chinese Communist Party build over time a very effective apparatus for controlling information inside China through censorship and propaganda, things that 20 years ago people thought would not be possible. President Bill Clinton had famously predicted that trying to control the internet was like trying to nail Jello to the wall. And yet the reality is that the Chinese Communist Party has been very effective in controlling the information environment inside China, despite the continued prevalence of tools like VPNs that allow, if someone's really dedicated, the ability to get out. The party has still been able to really control the narrative inside the country. And the party is now working to do the same for physical reality inside China, putting in place trackers to monitor people's movements, to link their cell phones with their face, to track where people are going and who they're talking to, and to extend this control over cyberspace now into physical reality. It's a very dystopian vision, and it's one where these investments that the party is making also accelerate AI development inside China. It's not just that the government is investing heavily in AI companies, although it is. And when I met with executives at iFly, for example, a major Chinese AI voice company, one of the things that they told me was that the government was responsible for half of their revenue. And that's a radically different political economy than what you would get, say, in the United States. Google or Meta doesn't rely on the US government for half of their revenue. And so the government inside China is spending a lot that's accelerating AI development. But even more importantly, that data is then being fed into algorithms, and it's refining those algorithms. And the ability to deploy these systems is improving it. Meanwhile, in Europe and the United States, the landscape for deploying facial recognition is radically different because of concerns that citizens rightly have about the use of facial recognition in public surveillance. Europe's leaned heavily into regulating AI technologies. The US has a much more laissez-faire approach to regulating AI, but we've seen in the United States a grassroots movement against facial recognition in public surveillance or by law enforcement. And in fact, a number of cities and states passing bans on facial recognition for law enforcement. And in the US, a number of major tech companies, IBM, Amazon, and Microsoft, have all either put a moratorium on the use of their facial recognition tools for law enforcement or just gotten out of the game entirely. So on the surface, it seems like maybe we're behind, and this is a problem. But what we don't realize is that what matters most in the AI revolution is not going to be deploying a system first or even having the best technology, but finding the best ways of using technology. And that's where our open societies in democratic countries, the United States and Europe and elsewhere, are a major advantage, because we can have people from across society working together to find the best ways of using AI. And so it's not going to be better data on faces that trains better AI fighter pilots, for example, to get a military advantage in AI. It's going to be civilian scientists and military professionals working together that's going to make that happen. So I want to talk through some of the key themes of the book, Four Battlegrounds, in which I argue that there are 4 key domains of competition in artificial intelligence. 2 of them focus on technical inputs into AI, data and computing hardware. And 2 of them focus on human inputs, human talent, the AI scientists and engineers that are needed to take these raw inputs of data and computing hardware and then turn them into useful applications, and institutions, the organizations that are needed to translate all of this into useful AI applications. And I argue in the book, which admittedly I'm coming from Washington, it is a very sort of US-China centric approach, that in the book, the United States and other democratic countries have a tremendous advantage over China in AI through advantages in hardware and human talent. In hardware, we've seen the United States, the Netherlands, and Japan over the last few months put together export controls on the underlying technology that's needed to manufacture cutting-edge chips, which are needed for the most capable AI systems. And that's potentially a massive advantage over China. And in talent, The United States and Europe have a pool of very talented engineers. And in fact, even though China is producing more AI scientists than anywhere else in the world, they tend to leave China. And so talent is another key advantage. And so what I'd like to do is just take a little time to walk through each of these areas about what does this competition look like today. One of the things that we want to try to understand when we think about how AI is changing global power is not just which countries are likely to move ahead, but how should we think about measuring national power in the age of AI? One of the things that the Industrial Revolution did was not just cause some countries to move ahead in terms of global power, but actually change the key metrics of power, where coal and steel became key inputs of national power. Oil became a geostrategic resource that countries were willing to fight wars over. So what is the new oil, to use an overused metaphor, in the age of artificial intelligence? You may have heard data is the new oil a couple of years ago. That was a big, a big claim that was going around, followed shortly thereafter by a bunch of articles in places saying, no, data is not the new oil. Like any metaphor, it has advantages and disadvantages, but there are some ways in which data has some similarities. Data is a valuable resource that can be collected and refined and turned to useful applications. You could think of data as the fuel that powers the engine of machine learning. Machine learning systems are trained on data, and in particular, large amounts of data. And having larger size data sets and a larger diversity of data is really valuable for training highly capable and robust machine learning systems. The first breakthrough in the deep learning revolution back in 2012 was based on progress against a database called ImageNet. And it was using machine learning algorithms for image classification. So looking at different objects in pictures and then identifying what is in this object. Is it a car or a horse or a person or a house or a bus or something else? And that development was powered by three key technical inputs to AI: improvements in the algorithms that are used to train machine learning systems, improvements in the hardware that's used. And in fact, originally it was progress in graphics processing units in the gaming industry that then enabled some of this progress in AI, and improvements in data. And there was a major project to build a massive data set for ImageNet using millions of labeled images that became this big enabler of the deep learning revolution kicking off. So we see the data is a key enabler of progress in artificial intelligence. Large models like ChatGPT, for example, are trained on hundreds of gigabytes of text, a good chunk of the text on the internet. Some have argued that China has an advantage in data for two reasons. One, because of its larger size, and because of the government's ability to spy on its citizens. Now, both of these things are true, but I think that China's authoritarian advantage in data is overstated. And when you look closer at the details, that in many ways, it's a relatively even competition between China and the United States and Europe in data. So why is that the case? Well, one is that it turns out that what matters much more than the national user base of a country is the user base of tech companies. And so has more internet users than the United States or Europe. US tech companies have global reach. Facebook has over 2 billion users globally, as does YouTube. Whereas other than TikTok, Chinese social media platforms have really struggled to gain a foothold outside China. WeChat, by comparison, has only 1.2 billion users globally. Diversity of data sets also matters quite a bit. And so Chinese tech companies will be well positioned to write algorithms to analyze the shopping habits of Chinese netizens, but those may not apply to markets outside China. And they're certainly not going to apply to, for example, military applications. It's also the case that while the Chinese Communist Party is aggressively spying on its citizens and collecting data on their behavior, those spying powers do not always translate over into Chinese companies. And in fact, the party has been increasingly cracking down on Chinese tech companies overall, reeling in them as an independent power base. On data privacy, in fact, the government has been pretty active in data privacy regulations, passing new regulations about consumer data privacy, not privacy from the government. And in many cases, following the lead that Europe has taken with the GDPR. And so the Chinese government, in fact, has passed comprehensive data privacy legislation, whereas in the United States, we still don't have any kind of federal data privacy regulations here in the US. The ecosystem, the legal structure inside China is weaker than in many other countries. And so it is still a bit of a wild west among companies in terms of what they do. But the party's been cracking down on Chinese tech companies, in part because of a spate of consumer data privacy scandals, but also because the party doesn't want anyone else to have the same spying powers that it has. And so in data, it's in many ways a relatively even competition. And a real data advantage is going to come from whichever companies or countries are able to take this data and then use it most effectively, refine it, label it, and apply it to useful applications. And the United States and China and Europe will all have ample amounts of data to do that. What's going to matter more is their ability to harness this data and use it effectively. Now, in the second battleground of this competition, computing hardware, it's a very different kind of dynamic because the United States and other allies have a tremendous advantage over China in computing hardware. So hardware is an essential component of building these highly capable AI systems. Large models like ChatGPT or the successor GPT-4 use massive amounts of computing hardware to train these models. They're using thousands of very advanced graphics processing units or GPUs running for weeks or months at a time. And without access to these very cutting edge chips, it's in large quantities, it's basically impossible to train these most capable AI systems. And this is an area where China has a tremendous disadvantage. China imports $400 billion of chips annually. There's a huge hardware gap that China has. And that's because China is a major assembly of a major role in the global economy of assembling finished electronic products and then shipping them elsewhere. But China is very weak in domestic chip production. And so they have to import those chips. And so a lot of chips might be designed in the United States, manufactured in Taiwan, using equipment made in the Netherlands and chemicals from Japan, and then sent to China for final assembly and then shipped everywhere else in the world. And so global supply chains for chips are heavily globalized, but there are these key choke points and key elements of the supply chain. For the most leading edge chips, 90% of them are made in Taiwan. Now that seems like a big disadvantage because Taiwan is an island 100 miles off the coast of China that the Chinese Communist Party has pledged to absorb by force if necessary. But these equipment that's used to make these most advanced chips comes from only 3 countries in the world. Japan, the Netherlands, and the United States collectively control 90% of the global market for the manufacturing equipment used to make chips. And in some cases, in fact, there's a monopoly. So for the most leading edge chips, the Dutch company ASML has a monopoly over ultraviolet lithography. One level down in the technology to the deep ultraviolet lithography, it's just Japan and the Netherlands that have access to this. And so those 3 countries can basically control access to who gets these most advanced chips. That's what we've seen the countries do in the last few months in export controls that the US came out with in October of last year. And then over the last couple of months in 2023, from January on, we've seen sort of information trickle out about Japan and Netherlands and them adopting similar controls. And they have been less forward-leaning and a big splashy public announcement about constraining China for obvious political reasons. They're not interested in angering China, but the information that's come out does seem to indicate that they've adopted similar levels of controls. This will be very effective in constraining Chinese domestic chip production. On legacy older model chips, China will still be able to compete. And in fact, the restrictions on this equipment going to China are very narrow and targeted only for the most advanced production. But that's where China struggled. And so China will not have the ability to make chips on its own. And then the US also put in place restrictions on Taiwan and Korea exporting the most advanced chips to China because they rely on US technology. And so China also being cut off from the most advanced GPUs that are needed to train these high-end models. Now, for the United States, in order for this to remain effective, it's going to need to continue to work with allies, making sure that these controls are multilateral. It's going to need to work with allies on investing in next generation research and development so that US and other allied companies stay at the forefront of this technology and maintain these kind of key dominant positions in the chip supply chain, that they're able to control access to this really valuable capability in terms of AI hardware. And there's another dimension of this that's really important, which is that as we see this shift in AI models to these very large, very capable models, that transition is pricing a lot of academic researchers out of competing at the leading edge of artificial intelligence. And so these models like ChatGPT are very expensive. They cost in the millions or tens of millions of dollars for the final training run. The total cost is even higher when you add up the experiments that are done beforehand, and the costs continue to go up. And so academics are priced out of being able to build these very large models. And a number of countries, the United States and the UK, for example, are exploring the idea of creating national resources for cloud computing for academics so that they can have access to computing resources, which is going to be really important for somewhat leveling the playing field so that we can continue to harness the minds in academia and some of the key advantages in the United States and Europe in competing in artificial intelligence. Now, human talent, the third area, is really critical for taking these raw inputs and then making use of them. And this is an area where, again, the global AI ecosystem is deeply integrated, and there's a lot of talent flows, but these net benefit the United States and Europe. So China produces more AI scientists than any other country in the world, but they don't stay in China. Over half of China's top undergraduates leave China and they come to the United States or to Europe for their graduate studies. And then they often tend to stay there. So for Chinese undergraduates coming to the United States to do their PhD in computer science, 90% of them stay in the US after graduation. And this is a major brain drain for China. It's a gain for the rest of the world. But universities and companies in the United States and other countries are a major draw for top scientists. And this is an area where the US and its allies can work closely together to harness our mutual advantages, making it easier for scientists to do visiting fellowships, to collaborate with others, is a huge advantage that democratic countries have, that China does not have that same set of global allies in terms of the ability for democratic countries to work together and to pool and to share human talent. Something like a Schengen area for AI scientists could be the kind of thing that could help unlock some of this potential in human talent and make it easier for scientists to collaborate. There are issues about intellectual property theft and academic espionage that are definitely real. China has been very active in trying to tap into the estimated 400,000 Chinese scientists abroad in terms of bringing back their scientific knowledge back to China. And this is an area that's been quite a bit of concern in the United States and other countries from a research security standpoint. China has an estimated over 200 talent recruitment plans. 1,000 Talents Plan is the perhaps most famously known of this, but there are many others. And we've seen in the United States, the US has been cracking down on some of these issues of intellectual property theft through investigations by the Justice Department. Better visa screening is another valuable tool to identify people that might be high risk, to have a targeted approach to improving research security and addressing issues of academic espionage and intellectual property theft without cutting off these broader talent flows. And that's the kind of guardrails that we're going to need to put in place so that we can de-risk some of these interactions and sustain healthy levels of engagement between Chinese AI ecosystem and that of United States or Europe and other countries. And this is an area where, as well, our allies working together can have collective benefit by sharing information, sharing best practices about some of these guardrails that we're seeing countries start to put in place to guard against some of these concerns. The last area that I want to touch on is institutions. And that's the organizations that can take these inputs of data and computing hardware and human talent and turn them into useful applications. This is an area where we see historically what comes out of major technological shifts in warfare is what's really critical is finding the best uses of technology. It's not actually building the technology first or having the best technology in some sense. Airplanes are a great example. So airplanes were invented in the United States. By the time you get to World War II, the US had no meaningful advantage in aircraft technology as a result of that. Aircraft technology had proliferated widely to all of the major powers. What mattered was figuring out, what do you do with an airplane? How do you use airplanes effectively? And there was a wide range of views among militaries at the time about the best uses for airplanes. In naval aviation, Great Britain was first to develop aircraft carriers, but they fell behind Japan and the United States in aircraft carrier development, not because of the technology, but because of internal bureaucratic and cultural reasons within the British military. And so it wasn't a lack of access to the technology that held Great Britain back. It was these challenges of their institutions and their ability to effectively employ this technology and bureaucratic and cultural reasons that got in the way. Meanwhile, Japan and the United States experimented with aircraft technology. The US Navy held a series of war games at the Naval College in the run-up to World War II, experimenting with how might carriers and other tools be used in warfare. And that led to quite a bit of innovation on both sides in World War II in the War in the Pacific. And so militaries that find ways to harness the best uses of this technology are going to be able to come out ahead and translate AI technology, which is coming out of the civilian sector, into increasing national military power. I want to end with a story that talks about how all of these key components of data, computing hardware, human talent, and institutions kind of come together. A couple of years ago, the U.S. Defense Advanced Research Projects Agency, DARPA, the sort of Department of Mad Scientists in the U.S. Defense Department, held an experiment to see if companies could train an AI system to achieve superhuman levels of performance at dogfighting in a simulator. It's a difficult challenge. We've seen in a run-up to this over the last several years, AI systems achieve human or superhuman levels of performance at a whole variety of different games, chess, Go, poker, computer strategy games like StarCraft and Dota 2. And for militaries, particularly for pilots, dogfighting is a challenge that has a lot of salience. A lot of air-to-air engagements are actually now beyond visual range using missiles, but it's an important crucible for pilots to test their skills. And it's an important area to demonstrate trust in AI systems and for pilots to begin to start trusting systems. So DARPA held this contest where companies could submit their algorithms, and the winner of this competition between different algorithms was a company that nobody had ever heard of in the United States called Heron Systems, very small defense company that was doing some innovative work on artificial intelligence. They beat out defense giant Lockheed Martin in the finals. And then their algorithm went head to head against a human pilot. And it absolutely crushed the human. 15-0, the human didn't get a single shot on the AI. Now, I should caveat that this is in a simulator, and there's a lot of differences between a simulator and the real world. although DARPA has now been working on taking these algorithms and putting them into real-world aircraft. And in fact, started doing flights in F-16 aircraft in December of last year. And so one of the things that's really interesting about this was not just that this AI system was able to beat the human, but that it did so by operating in different ways than the human did. And that points to some of the potential of AI, not just in military operations, but across society, to not just be better than humans, but to do things differently. One of the things that the AI was able to do was to execute these split-second head-to-head gunshots when there's a brief moment where the aircraft are racing at each other head-to-head at hundreds of miles an hour, and there's just a split second to get off a shot, requires superhuman levels of precision, very difficult. It's almost impossible for humans to do. And in fact, it's banned in training for humans to even try this because it's dangerous when the aircraft are racing at each other hundreds of miles an hour. The pilots seem to be focused on avoiding a collision, not trying to line up their aircraft nose to nose. The AI system could do this. It could do it without having a collision because it can do both things at the same time. And what was really interesting is that it did so without being programmed to do this. The AI system actually learned to do this entirely on its own. It came out of the training that it had done. So how did this company that nobody ever heard of, well, started by building the data that they needed. They built a competitive league of AI agents. They had over 100 agents competing in this competitive league where they were operating against each other in simulated dogfights. Some of them using generalist systems that tried to be overall good. Some of them were specialists focusing on one particular aspect of dogfighting, just like you might try to train a balanced martial arts fighter, having them compete against people with different skills. They did the same with this competitive league of algorithms. And the winning algorithm had over 30 years of flight time in these simulators. So they built the data that they needed. In terms of hardware, they had a hardware stack running in their offices 24/7, churning through these simulations at accelerated speed. So when I visited their offices, there was this roar in the background, and they showed me their attempt at a soundproofed server room. It was still quite loud, where they had this stack of GPUs churning away, doing these simulated dogfights, training the next generation of their algorithms. They harnessed their human talent by giving their engineers one day off a week. Every Friday, they had fun Fridays for the engineers to take on whatever they wanted to do, which when you think about it, is a massive commitment of a company. That was 20% of their engineers' time. And one of their engineers was really excited by progress in reinforcement learning that was coming out of DeepMind at the time, and had trained an AI bot using this technique called reinforcement learning to play the video game Doom, the first-person shooter game. And not obvious what the applications were, but when they were pitching DARPA on being accepted into this challenge to be allowed to compete, they had their Doom bot running in the background in their pitch deck. And this was the thing that actually caught the DARPA program manager's eye, because this was a demonstrated application of this very cutting edge technology at the time, reinforcement learning, in a real application. And they said, okay, we've seen that you've done this. We want to give you a chance to do the same thing now for dogfighting simulation. And it was DARPA creating the institutions necessary that could harness all of this, giving a company that nobody had heard of the opportunity to compete in this challenge, to go against some of the biggest defense companies, and the opportunity to win and then go on to follow on development, which we're seeing already happening. And so all of those things, data, computing hardware, human talent, and institutions coming together, enable progress in this domain. And that's also what's going to enable progress across a whole wide variety of applications. And those that are able to find advantages in these key areas are going to have huge advantages in the changes that we're going to see in the AI revolution. So thank you all for taking the opportunity to join this discussion and talk with me today. And I look forward to your questions and conversation. Thanks so much.